For many years, the word impossible has appeared relatively routinely in space science headlines. In this context, the word actually means that a particular discovery is impossible to reconcile with standard scientific theory. From that premise, virtually every type of object and phenomena in the cosmos has at some point behaved, quote, impossibly. We've seen comets, asteroids, moons, planets, stars, galaxies, and galaxy clusters all occasionally behave in ways or reveal characteristics that confound all conventional predictions and reasoning. And yet there is no question that such objects, regardless of how puzzlingly they may seem to behave, do in fact exist. However, the same cannot be said of hypothetical objects and entities for which the word impossible takes on a very different meaning. This includes, quote, impossible neutron stars, which appear to shine with a brightness of 10 million suns, or rotate at 1/4 the speed of light. It includes so-called magnetars, which release more energy in 1/10 of a second than the sun produces in 100,000 years. It includes hypothetical, quote, immortal stars, which supposedly find a continuous fuel source in the form of dark matter. It includes dark matter itself, an invention used to account for many apparent anomalies, including mysterious gamma-ray emissions at the heart of the Milky Way. And of course, it includes black holes, whose very existence is directly challenged by the plasma cosmology model of a plasmoid at the galactic center. I'll discuss the plasmoid and its ability to account for the enormous energies, mass, and various phenomena attributed to black holes a bit later in this presentation. Now, we do see a degree of candor and humility from individual astronomers who freely acknowledge the, quote, impossible nature of some observational data. However, rather than serving as a gadfly, which might inspire scientists into exploring genuinely new theoretical pathways, if anything, we see a doubling down of commitment to theories which should, in the cold light of day, be recognized as discredited. A very salient example of this can be seen in recent attempts to explain just one of the devastating findings of the James Webb Space Telescope for the standard Big Bang lambda-cold dark matter model of the universe. Let's consider a paper recently accepted for publication in the Astrophysical Journal Letters, which was summarized by Brian Koberlein in the article, "The Early Universe Let Black Holes Break the Rules," briefly. Koberlein begins, "At the heart of the Milky Way, just 27,000 light-years from Earth, there is a supermassive black hole with a mass of more than 4 million suns. Nearly all galaxies contain a supermassive black hole, and many of them are much more massive. The black hole in the elliptical galaxy M87 has a mass of 6.5 billion suns. The largest black holes are more than 40 billion solar masses. We know these monsters lurk in the cosmos, but how did they form?" End quote. Now I have to interject here. The unassailable certainty with which the author describes the very existence of black holes is not appropriate. As longtime viewers know, mathematician Steve Crothers long ago challenged the very mathematical foundations of black hole theory at past Thunderbolts conferences. He presented evidence that black holes, as described by the Hilbert, Schwarzschild, Droste solution, are mathematically invalid and do not exist in the theory of general relativity itself. With regard to the title of Koberlein's article, as longtime viewers also know, black holes, quote, break the rules more routinely than modern heads of state violate international law. I can't count the number of problematic black hole discoveries I've reported on in the last couple of decades, which could and should have forced a fundamental challenge to the black hole question. Nor can anyone claim that plasma cosmology has not offered a plausible and testable scientific alternative. This includes Eric Lerner's peer-reviewed papers on his plasmoid model of quasars and active galactic nuclei. As we've noted many times, plasma is scalable, and unlike black holes, does not include the reification of non-physical concepts such as space-time. Koberlein continues, "One idea is that supermassive black holes form over time through mergers. Because of dark matter and dark energy, galaxies formed in clusters separated by voids. Over time, the voids grow larger, while the galaxies cluster together and eventually merge. The black holes within those galaxies also merge to form the supermassive objects we see today. Of course, that takes time. If that model is correct, the most distant galaxies should have smaller, million solar mass black holes, and we should only see the billion solar mass giants in the nearby universe. But observations from the James Webb Space Telescope found that the supermassive black holes in many of the most distant galaxies are huge. Black holes with a mass of more than 1 billion suns already existed when the universe was only 500 million years old. Those young giants are too massive to be explained by mergers, and they defy conventional explanations." End quote. I have to interject again. A recitation of all the JWST discoveries that undermine, or to put it more bluntly, falsify the standard Big Bang origins of the universe would require a much longer presentation. Only in this context can anyone meaningfully appreciate individual anomalies, which, quote, defy conventional explanations. This includes the appearance of apparently massive galaxies much too early in the Big Bang epoch, stellar populations in so-called ancient galaxies, which show the signatures of much older stars, as well as stunning images of Stephan's quintet, showing this quasar, which is supposedly roughly 10 billion light-years away, clearly in front of the dense dust lane of a galaxy which is only about 300 million light-years from Earth. Recent scientific studies have also confirmed that the apparent current expansion rate of the universe is too rapid to explain by any conventional reasoning. All of which is to say, JWST has done nothing but affirm the thesis of Halton Arp that cosmological redshift is intrinsic and is not a reliable indicator of an object's distance from Earth. In other words, the evidence has never been stronger that the universe is not expanding, there was no Big Bang, and in truth, the universe is of unknown age and extent. In fact, the observations of the so-called early universe are so disruptive to standard cosmology. The research we're discussing here proposes an epoch free from the constraints of a governing rule of physics, the Eddington limit. As Koberlin explains, the Eddington limit is the fastest rate a black hole can grow. This rate isn't fast enough to account for all the giant black holes we see in the early cosmos. But the earliest period of the universe is very different from the universe today. What if the Eddington limit didn't apply back then? This is the question examined in a recent study. The authors created sophisticated hydrodynamic models to look at the formation of black holes during the cosmic dark age. Now, the authors propose a, quote, super Eddington period where supermassive black holes had a golden age in which to form, thanks to all the extreme density of material close to a black hole, which could not be cleared. However, as Koberlin acknowledges, this allowed early black holes to grow at a rate faster than possible today, but only up to about 10,000 solar masses. According to the simulations, after that, the Eddington feedback loop kicks in, and the growth rate is limited again. The team also found that the super Eddington growth doesn't help much in the long run. Eventually, even black holes that always grow at a sub-Eddington pace will achieve the same mass. This study strongly suggests that super Eddington growth can't explain all the billion solar mass black holes we see in the early universe. In other words, even after proposing an epoch which discards a rule of physics, the cited studies still cannot come close to explaining the problematic data. So I have to ask, in modern cosmology, why is it considered more acceptable to engage in ad hocery which discards rules of physics, rather than question the fundamental integrity of the Big Bang story itself? After all, when astronomers observed that the expansion rate of the universe appeared to be increasing over time, the result was not a rethinking of Big Bang theory. Rather, it led to the invention of another novel entity, called dark energy, whose existence remains unproven today. This is the pattern of thinking and conduct that has resulted in the ever-deepening, intractable crisis at the heart of cosmology. When space scientists observe objects and phenomena whose very existence is, quote, impossible in standard reasoning, the response is not a rigorous re-examination of fundamental theories and assumptions. Instead, we see ad hocery, which only serves to sustain discredited and dying theories. It must also be noted that, quote, impossible or rule-breaking black hole discoveries are certainly not limited to the so-called early universe. As noted in the Science Alert Report of November 14, 2025, magnetic fields could explain impossible black hole merger. In 2023, gravitational wave detectors picked up the signature of a collision 7 billion light-years away. Two black holes had merged in an explosion of warped space-time, but when astronomers analyzed the data, they found that something violated the rules of physics. The black holes were spinning faster than any previously observed, and fell within a mass range where black holes simply aren't supposed to exist. In this case, investigators took the ironical path of exploring the influence of magnetic fields on the hypothetical spinning black holes. I call it ironical because cosmic magnetism itself was not predicted by mainstream astrophysicists. Further, the colossal magnetic fields of galaxies have been found to be, quote, astonishingly well ordered, in defiance of the belief they were created by chaotic processes like supernova explosions. What produces magnetic fields? One thing: electric currents, which we see in the interstellar and intergalactic medium in the form of filaments that connect objects at all scales throughout the cosmos. Although the word impossible appears fairly regularly in science headlines, one thing that is not only possible, but definitely real, is a plasmoid. First coined by the MIT physicist Winston Bostick well over half a century ago, according to plasma cosmologists, plasmoids at the centers of galaxies concentrate and store electromagnetic energy from inflowing electric currents. When a threshold density is reached, these plasmoids discharge energy, usually along a galaxy's spin axis, forming galactic jets and X-ray emissions, which astronomers can only attribute to black holes. Again, peer-reviewed scientific papers on these concepts can be found in the IEEE Transactions on Plasma Science, which has featured many special issues and articles on plasma cosmology, including the cosmological role of the plasmoid. In other words, mainstream cosmology is in such an ignoble and misguided period, its defenders are more willing to discard rules of physics in service of ad hocery, rather than consider the well-developed, peer-reviewed concepts of plasma science. The state of affairs only grows more desolate with each impossible discovery.